So hey there, welcome back to another video. Today we'll learn about Chatty I. What is Chatty? Chatty थोड़ा name थोड़ा different है, but Chatty I means the input-output operations, right? So let me write the topic. Okay. The cumulative effect of a large number of input-output requests can have a significant impact on performance and responsiveness. So what it means that whenever you have any server and you have a client and there are many input-output requests, they are talking to each other via APIs, right? Which means there will be many input-output requests. So this will make your UI laggy, right? So network calls and other input-output operations are inherently slow compared to compute task, right? If there is any compute task, let's say this is our client, which is our front end, and this is our server, right? Now, if there is any computation task on front end device itself, right? Device itself, this is the device. If there is any computation task, that will be faster rather than going to the server and getting any data from it, right? So that's what it means. Each input-output request typically has significant overhead, and the cumulative effect of numerous input-output operations can slow down the system. Of course, if you have various input-output operations, then it can of course slow down the front-end system, right? Now there is one more thing. If you see, you might know this on front end. Now we can use this thing. Let me just show you. Yeah, what you can do, you on front end, if you are using JavaScript, you can use request idle callback. Okay, so this is the callback function. Okay, so what it does, so let's suppose that you want to run any task in background in front end, right? So what it will do, so unlike the traditional methods that demand immediate execution, right? So if you are running anything and if it demands immediate execution, request idle callback, what it does, it operates differently. It essentially tells the browser that let me know when you have some free capacity, and I will discreetly handle this task without disrupting the user experience, right? If there are any ongoing tasks on the browser, this is our browser, right? This is our browser. And if there are any ongoing tasks, let's suppose if there are any computations that are happening on the background, then it will check with the browser that do you have any free space available. If it does, then only it will execute itself. So this is the best way to get a performance boost on front end. So chatty input output. So here are let me write some common use cases of chatty. So the first one is reading and writing individual records to a database as distinct requests. This is a very classic example actually. Whenever you are writing SQL queries or creating an API to write in DB, what you can do, you should write in bulk instead of creating a smaller request. We have a form, right? We have a form. Inside form, we have various fields to change, and at the end, we have the save button. So this is a classic example. Instead of having save button on each and every after each and every input, we have a common save button which takes all the request or update request in bulk and try to update it, right? So read and okay. So this was the first example. Now second is implementing a single logical operation as a series of HTTP requests. So if there is any logical operation that is happening on your backend, so like if I want to have some computations, right? Computation can be of anything. It can be like give me image. Let's take an example of AI, right? In AI, what we do, we try to request an image of scenery, right? So instead of requesting one image, what we can do, we can ask it to generate 3 images simultaneously, right? This will save us some time. And so instead of single logical operation, we created a series of HTTP requests one by another, and this can be async as well, right? These operations can be async. Depends on the server capacity. Now the third example is reading and writing to a file on disk. If you are reading and writing a file on disk, what it means, if there is any txt file and you have a code editor, okay, and you are updating this txt file via code editor line by line, which means there will be various update operations in this .txt file. So that is also an example of input output, and that will create some lagginess on your front end, right? So what you can do, you can just have a save button or have a shortcut known as Ctrl+S to save your file. You can have concurrency as well. VS Code provides it, but that can be like every 5 seconds. That would save some lagginess. That was about chatty input output. Now let's learn about retry storm. So retry storm. What is retry storm? Retry storm refers to a situation in which a large number of retries are triggered in a short period of time. So let's take an example of YouTube. Right? YouTube. So on YouTube, on your phone, what you try to do, you refresh it multiple times. Refresh it multiple times, right? So the refresh icon. So you pull down and refresh it, right? You do it multiple times. So this multiple retries is known as retry storm. What it does, it updates your feed, right? Leading to a significant increase in traffic and resource usage. Now, when you try to refresh it again and again, your traffic on your server, like single device will have 2-3 requests because you have refreshed it 2 times or 3 times. So that will increase the traffic on server. This can occur when a system is not properly designed to handle failures or when a component is behaving unexpectedly. This can of course lead to performance degradation. Performance can peak and decrease a lot, and to increase network traffic will increase, and poor user experience. Okay? UX will be poor. The multiple requests, it will become laggy. So there can be multiple approaches. One of the brute force approach that I can think of is what you can do. You can try to implement a time something. I'm not sure what it is called, but in a time frame. Let's suppose there is a time frame of if the first request is made just before 5 seconds. So just try to continue with it. In this 5-second interval, don't expect any more requests for refresh. Just try to pass the same field, okay, every 5 seconds. That can help to decrease your server utilization. Okay. So to address retry storm, a number of approaches can be taken, such as exponential backoff, circuit breaking, and monitoring and alerting. Now let's learn about what are these patterns. Right? Let's first learn about exponential backoff. What is this? It is a network error handling technique where a client waits increasingly longer before retrying a field request to a server, often doubling the wait time with each attempt. This strategy implemented on the client side prevents overloading a temporarily unavailable and overloaded server. So what we are doing here, what we are doing in exponential backoff is we have this is a network error handling technique, right? First of all, now where a client waits increasingly longer before retrying to a server. So if there is any field request to a server, it will wait for some time. So I can think of a classic example of this. I think IRCTC website, if you try to log in and the login is failed, there is some wait time. I mean 5 minutes or something. Also in ICI Bank or LDFC Bank, if you try to log in multiple times, or even in on the bank portal, if you try to log in multiple times, you will see that there is some certain wait time. Even if in our log system on iPhone or Android phones, if you try to enter wrong password multiple times, there is some wait time, right? So same applies for the network. If you retry multiple times, you have to wait for longer, and this time will keep on doubling each time you are wrong. So that was about exponential backoff. Now there is one more technique, which is circuit breaker pattern. So this design pattern is distributed that prevents repeated calls to a failing service, enhancing resilience and avoiding cascading failures. It works like an electric circuit breaker, switching to an open state to stop request when too many failure occurs, then moving to a half open state to test recovery, and finally returning to closed if successful. This cycle helps prevent overload, allows failing services time to recover, and provides a fallback response instead. Our requests are allowed to pass through the service as normal. So there are 3 states in circuit breaking technique. The first is close. So requests are allowed to pass through the service as normal. If it's in closed state, which means the request can pass normally from the service. Open, the breaker blocks all requests to failing service. Now, if it's open, if your circuit is open, it will block all the requests to the failing service. So requests are immediately rejected or redirected to a fallback response. This state lasts for a specific timeout, right? It will make sure that your service get recovered, right? If it's closed, which means I can explain it in some way. Let's see this circuit breaking, right? Circuit breaking. This is our circuit. This is closed for now, right? This is closed, which means this is closed. The requests are coming, bypassing it to a service. Now it's open. Let's suppose this is open. Okay. So a service. Now the requests. These are the requests. So your requests that are coming, it will get blocked, and it will send some fallback response. Some default fallback response that the service is down. And what it will do, this will be for a specified period of time, let's suppose 5 seconds or 4 seconds or whatever it can be. Now what it will do, whatever requests that are going back, it will make the service, our service will get some time to recover, right? That was the open thing. And now half open. After the timeout, a limited number of test requests are allowed to pass into the service. Half open means okay, this can be half open actually. So if you see, this is full open, right? This is full open. Half open means so this is our pipeline. This is a half open. So half. These are our incoming requests. Okay. Some will be blocked. Some will be passed. Okay. So n number of requests will be passed to the service. Okay. So our service can run properly and smoothly, and it will get some time to recover in the meanwhile, right? So that was about circuit breaker pattern. Now benefits. What are the benefits of circuit breaker pattern? Of course, first is prevents cascading failures. A single service failure from, if your service fails, what happens? Your backup service gets up, right? Master slave architecture. In case you don't have that, then this circuit breaker pattern is obviously a best choice. It improves resilience, allows the system to function even when dependent services are down or unavailable. If you use half open pattern in the circuit breaker pattern, then this is of course advantage of it. Avoids resource waste, of course CPU cycles or network resources on endless retries or fail. Whenever you have multiple retries, what it will do, it will try to serve each and every request, but it will prevent on doing this. This circuit breaker pattern now provides graceful degradation. Enable the system to continue running by using fallback responses, providing a better UX. Right? So that was about now monitoring and alerting. What is this? Let's monitoring alerting system. Let's learn about monitoring and alerting system are the tools and techniques used in operation to track the performance of various system components. So basic monitoring and alerting means that we will try to monitor our server. We'll try to check if it's healthy. If it doesn't have any load, then we'll make sure that it continues to serve the request. If it does have any load or the performance is around 90 to 95%, then we'll try to make sure that the incoming requests are we serve some of the requests, so that the load on the server can be balanced and not all users our service doesn't go down. So that was about retry storm.